Hello everyone, my name is Zishan and welcome to Zishan classes. We're gonna look into another question from the chapter Kinematics, and the problem is that this is an L-shaped device. It's rotating in the anti-clockwise manner, and there's a spring attached with a sleeve. We have to find the extension in the spring. The point is that when this device rotates, there is bound to be some extension in the spring, due to which the sleeve moves up or down this rod. What is a sleeve? Sleeve is an object which is free to move about a rod or a thin bar. So we're gonna have to find the extension X on the spring. We know that the spring constant is equal to K, and the velocity with which, angular velocity with which this device is rotating, it's omega. Okay, so we gonna have to draw the free body diagram of the sleeve. Also, we are going to look into the extension in the spring. If the original length of the spring was L, let us assume that the spring has extended by a length X and the new location of the sleeve is A. Now let us talk about the forces acting on the sleeve. I'm going to draw the sleeve here. This way there is going to be a normal force. This way it's going to be the force by the spring, which is always given by the expression K into X. K is the stiffness and X is the extension in the spring. Also there is a force downwards, mg, but we don't need to worry about it. It has no contribution in the motion in this plane. So these are the two forces. We are going to draw these two forces here, and now the rotation of the sleeve A along with the whole device is taking place this way with an angular velocity omega. If the radius of rotation is given by r and this angle equal to theta, we know that by simple geometry this length is going to be r cos theta. Also, we know that this length is equal to the length of the spring plus the extension in the spring. This is equal to this, L plus X. We will keep this thing here as an equation we are going to use later. R cos theta is equal to L plus X. We'll name this 1. Also, we should know that this is a rotating body and the acceleration of the sleeve is directed towards the center and is given by A equal to V square divided by R. This is the centripetal acceleration. The centripetal acceleration. equals to V square divided by R, directed this way. So these were the two things that we should know before we start with the problem. That r cos theta is equal to L plus x, and acceleration of this sleeve is directed towards the center and is equal to V square by R, or omega square R. I'm going to erase all other things and keep the sleeve with us and the force is acting on it. The acceleration is directed this way, A, where this angle is equal to theta, because we have assumed this angle to be theta. We will write the equations of motion for this sleeve in the directions along the acceleration and along the perpendicular direction this way. Now, since this angle is equal to theta, the force Kx can be broken into two components, Kx cos theta and Kx sin theta. Similarly, the normal force can also be broken into n sin theta and n cos theta. What we have done here is we have broken the force F equals to Kx and the normal force n and F equals to Kx into two directions, this way along the acceleration and this direction which is perpendicular to the acceleration. Now we are going to use these components in our equations. So let us talk about the direction equations for the direction along A, acceleration. It is going to be Kx cos theta plus n sin theta is equal to m into A, which is equal to m omega square r, equation number 3. Now we will talk about the equations for the direction which is perpendicular to A. It's going to be Kx sin theta is equal to n cos theta. Kx sin theta, the component of Kx, and n cos theta, the component of n, are both equal. We have acceleration only in this direction, so these two must be equal. We'll name this 4 and write it here. So we have two equations involving our object, which is the extension x. We have to solve to find the value of x. We have to solve these two equations to find the value of x. It's very simple. What you do is you put the value of n, which is equal to Kx sin theta divided by n divided by cos theta, in the equation number 3 here, n. You put the value this over here. What you get is Kx cos theta plus n, which is equal to Kx sin theta divided by cos theta into sin theta equals m omega square r. We have put n equal to this in equation 3. This gives us kx cos square theta plus kx sin square theta equals m omega square r cos theta. This can be reduced to kx. This can be reduced to r cos theta. We know the value of it, L plus x. Now we have to solve for x. Expanding this, we get m omega square L plus m omega square x. Taking x to the left side, we get m omega square x equals m omega square L. This gives us x is equal to m omega square L divided by k minus m omega square, which can also be written as L divided by k divided by m omega square minus 1 x. So we have arrived at the value of the extension in the spring. Our objective was to find the extension in the spring. We adopted two concepts, one including the geometry of the arrangement and one which we already know about, the centripetal acceleration, and we used the forces acting on it to create the equations, and we solved the equation for x. That's it. I'll see you in another question, another video. You have a good day. Bye.